Assalamualaikum and a very good day. Welcome back to our new episode. My name is Khair Najwa and together with my co-hosts Shifa Amira and Safwan Azrai, we will have a very special guest that will reveal the latest innovation of technology to help gathering evidence in crime scenes. This honored guest has published the journal titled Crime Light Imaging, a novel sensor for standoff detection and localization of forensic traces in July 2023. Let us welcome the writers of the journal, Jima Montalvo, Violeta Lezik, and Andrea Chiri. As we all know, investigating crime scenes is a very complex task and it is crucial to find new and better ways of gathering evidence without disturbing it. So, Mrs. Montalvo, it was mentioned in the journal that as of now, we use crime light imaging or CLI in the investigation of crime scenes. Can you explain how does the CLI work?
Thank you, Ms. Najah, for the great questions. CLI help uncover hidden traces like fingerprints or body fluids, assisting in identifying hidden evidence from a distance up to 10 meters. It is a tool that employs alternate light source ALS, which provide monochromatic light at specific wavelengths to detect many types of traces using different LED wavelengths. As we can see in the screen, fingerprints, fibers, and bodily fluids can be exposed using UV light at a specific wavelength. Other than that, drugs, blood, and question document use visible and near IR at 520 nanometer and 850 nanometer respectively. Then CLI can also be used in aiding the 3D reconstructions of the crime scene. Besides that, in the journal, for example, photograph for fingerprints on a silicon wafer. Is taken from a 7 meter distance, and it can be clearly seen that when green LED lighting at 5 to 5 nanometer was used, the ridges and the particles were seen very distinctly. The noise was also reduced compared to when no LED light and blue LED light at 455 nanometer were used.
Wow, that is very interesting. I read that this instrument hardware was split into two parts, the sensor head and the instrument box. Mrs. Lazi, can you explain more about this part?
Sure, thank you so much for asking this question. The sensor head actually contains HD color camera, objective lens, and lighting equipment. It was then connected to a cable that include electrical and communication wires, as well as an optical fiber to transmit the light. The instrument box was also occupied with the 4 LED light sources mentioned earlier. It also has a control unit for managing cable connections, and this design has helped us to reduce the instrument's weight and most importantly, improve its efficiency. It also has 5 hardware components to manage the function of the instrument. Alright, so for the hardware components, firstly is the illumination system. It uses LEDs and optical devices to illuminate crime scenes, revealing hidden traces using different wavelengths. And the second one is the detection system, which uses a high definition color camera and optics to capture images of the crime scene. And third is the laser pointer or distance meter. It serves as a laser pointer for reference and helps measure distances. It's one of the very crucial components for accurately reconstructing the crime scene. And also the device uses a high frequency laser distance sensor with a range of 0.03 until 60 meters and accuracy of 1 millimeter only. The fourth hardware component is the electric control. It supports the CLI system by using a custom electronic system powered by 12 to 24 VDC, synchronizing an LED light source with the camera detector. It also controls the LED's focusing optics and filter wheel. And last but not least, the MPS is a remote control system that can host any compatible standoff sensor for a fixed point measurement and scene exploration.
So next, I want to ask Andrea Chiri. Mrs. Montalvo mentioned that many hidden traces like fingerprints and body fluids can be detected using the CLI. So how do you collect the samples to evaluate the performance of this presumptive test? Is there any sample preparation need to conduct it prior to analysis?
Yes, there is. To test the performance of these instruments, the fingerprints were collected by washing the donor's hands, and next we rub the fingertips together to distribute their secretions and transferring them to a silica water with 1 kilogram of force by using lever mechanism for 5 seconds. Next, the bodily fluid samples like blood and semen samples from healthy donors were collected and tested. The blood was placed on the black cotton and left to dry for 24 hours, and the semen sample was collected on a white cotton.
I see. So, at what distance the fingerprints, bloodstains, and the semen samples were photographed, and why does this distance were chosen?
Fingerprint and semen stains were photographed at 7 meters, while blood stains were examined at both 5 meters and 7 meters to assess their visibility and characteristic under different distance. It was proven that even at 7 meters, the traces can still be detected using CLI.
This topic is very interesting as the CLI can resolve fingerprint ridges and detect hidden traces like blood and semen on various surfaces, even at a distance of 7 meters, actually up to 10 meters. This innovative instrument represents the first true stand-off crime-like imaging system, offering versatility and a portable design to adapt to specific applications. If there is any further developments in the future, the researchers will need to focus on reducing the impact of ambient light during the measurements. This work promises a new and effective approach to forensic science crime scene investigation. Till we meet again in the next episodes with more innovation and inventions to aid forensics in solving crime cases more conveniently and hopefully with less cost, energy, and labors.